right, welcome everybody to the OMNI-494 and 498 product launch. This is an internal launch, and these antennas are both dual band Wi-Fi MIMO marine antennas. Just as a disclaimer, so if you see or if you hear me interchanging MIMO and MIMO, it's actually the same thing. I actually mean the same thing, so don't be wondering what I'm talking about. So we currently have only one Wi-Fi antenna for marine application. That's the OMNI-496. It's a SISO antenna. SISO stands for single input, single output, meaning it only has one antenna. Let me just get my pointer going here. Okay. It only has one antenna in the enclosure. So we thought of expanding our Wi-Fi antenna range for the marine industry to have more than one antenna in one enclosure, hence the OMNI-494 and the 498. So why MIMO Wi-Fi? So this is a question that we foresee that the sales representative will be asked a lot, because our current version is a SISO, so it's only one antenna, and now we've moved and added more than one antenna in the enclosure. So on the image here on my right is just a simple illustration to show you what MIMO is. So MIMO stands for multiple inputs, multiple outputs. So it's more than one antenna at the transmit end and more than one antenna at the receive end of a wireless link. So if you want more information on MIMO, what is MIMO, how you can achieve MIMO, and advantages of MIMO, Andre Fourie has done a lot of videos on our YouTube channel. So you can head on to and check our YouTube channels and you'll understand more the importance of MIMO. So I'll just list a few of these advantages of having MIMO over SISO, with the first one being increased data throughput. You'll have increased data throughput due to multiple data streams being sent from the different antennas. As you can see here, it's indicated with the green and the red. So the different, so this antenna is sending that data stream, and it will be received by the different antennas there. And by doing this, it's increasing the data throughput. And then we'll have an increased range and coverage. So MIMO actually employs spatial diversity, and by doing this, it increases the range and coverage of the signal. It supports, well, let me just say, if there are signal reflections, MIMO will constructively combine these signals, and then it will enhance the reliability and make sure that the signal is of high quality, and it will be able to support more users as it would have when you're using only one antenna, and also data-intensive applications without sacrificing performance. So these are just a few advantages of using MIMO over SISO that I've listed here. But if you want to learn more about this, Andre has explicitly explained about this in our YouTube channel. So why do we need Wi-Fi on board a vessel? So definitely we need to communicate. So the crew members on board and the passengers on board, they need to stay connected with their loved ones and colleagues while at sea. There's also the crew welfare. So this is especially for the crew members that spend long period of time away from home. So they need to have a sense of belonging, so they can access their social media platforms. They can be able to read news. They can be able to play games just for their sanity and also to improve their quality of life. And for passenger experience, this is especially for the water vessels that have entertainment options. So you can be able to make onboard services, bookings, activities, and making reservations if this is available on the water vessel. And also you can be able to access ship-related information. For the crew members, they can be able to access real-time weather updates and navigational information, which is very crucial for the safety and efficient operation of the ship. And having Wi-Fi on the ship or the water vessel will be used as a backup in case of emergencies. So in case of emergency and you have that Wi-Fi connection, you can use it to communicate with onshore authorities or other nearby vessels for help. So also, this is not all the benefits of having Wi-Fi on board, but some of them, which we thought it's important just to put out there, because these are questions that you may be asked. Why do I need a Wi-Fi antenna on board? So these are some of the advantages that you can list. All right. So on this slide, I'd like to compare the Wi-Fi antennas for marine applications. So we'll start with the 496. So this is our current Wi-Fi antenna that supports, it's a dual band Wi-Fi, so it supports 2.4 to 2.5 gigahertz Wi-Fi and 5 to 6 gigahertz of Wi-Fi band, and also the 5G CBRS band from 3.4 to 3.8 gigahertz. So just to note, this is the V1 version. I was told we will be developing the V2 version. We just need to run out the V1 first, and the V2 will go up to 7.2 for the with time. These new antennas, the 494 and the 498, they will cover the lower end of the Wi-Fi band, which is 2.4 to 2.5 gigahertz, and the higher end, 5 gigahertz all the way to 7.2. So by doing this, they'll be compatible with access points that are using older technology for Wi-Fi or newer Wi-Fi technologies, which is Wi-Fi 6E as it is right now, which covers the 6 to 7.2 gigahertz band there. So let's dive in to the OMNI-494. So as the name, as you may have noticed, most of the antennas that have this 4 here at the end, on the product code at the end there, it's not all, but most of them that have a 4 here, it actually means there are 4 antennas within the enclosure, and it either has 4x4 MIMO cellular or 4x4 MIMO Wi-Fi. So apart from antennas like the PAC4 and I think the 704 that do not have 4 antennas within the same enclosure. So for the OMNI-494, it definitely have 4 antennas. And I thought it would be nice to just visualize what is inside the radome. So this is how it looks on the outside. We are using the OMNI-402 enclosure, so we did not go out of our way to develop another enclosure. So we are using the 402 enclosure. And then what is inside is what is different. So the OMNI-494, as I mentioned, is a 4x4 MIMO Wi-Fi cross-polarised antenna. What that means is it has this vertical, I'm hoping you can see my cursor there. So we have vertical elements here and here too, and then we have horizontal elements there and here. By polarized, excuse me, it means they are orthogonal to each other or perpendicular to one another, the horizontal and the vertical there, and the horizontal and the vertical there, which is very important, especially when a signal travels from the transmitter to the receiver. It may go through obstructions, and then when it is reflected, the polarization of the signal will change. So if you only have one polarization at the receiver end, you may completely miss the signal, or you will not even receive the signal. But if you have more than one polarity, which is what we are having with the 494, there's a very high chance you will not miss the signal, and you'll have a good quality signal at the receiver there. So the 494 is a cross-polarized antenna with vertical high-gain elements, which are these guys here at the sides, and low-gain horizontal elements, which is this guy here at the top and at the middle. They are all dual-band Wi-Fi antennas covering 2.4 and 2.5 gigahertz band, and the 5 all the way to 7.2 gigahertz band. The peak gain for the vertical elements is 9.8 dBi, and the peak gain for the low gain elements, which is the horizontal ones here, is 5 dBi, which gives you, if I can just say, best of both worlds, because the low gain antennas will give you a wider beam width and will give you good coverage, especially for users that are close to the access point, and the high gain will give you distance. So the users that are further away from the access point will still get good coverage and get good signal, even if they are far from the access point. So it's a best of both worlds. On the mechanical side, the antenna is IP68 rated against dust and water ingress. Additionally, it's foam filled, making sure that no water will get into the antenna, even when there is harsh weather at sea. The radome is salt water and UV protected, so it's not easily corroded. It can function all the way from -40 to 80 degrees Celsius. So this is a rating that is common in all our antennas. And it comes with 4 cables. So each antenna has a cable connected to it. So these are 1, 2, 3, 4. It has 4 cables coming from the antenna. They are all 2 meter long and they're HDF 195 cables. And at the end here, they terminate to SMA male and connectors. So we will provide adapters. The RP stands for reverse polarity, SMA male to SMA female adapters that will enable users to connect the antenna to their access points. Remember, Wi-Fi connectors are mostly RP or reverse, so it can be a reverse polarity SMA or reverse polarity N-type mostly, among others, but it's always a reverse polarity connector. So we will provide an adapter, and in this case is the SMA RP SMA adapter because our antenna comes with SMA connectors. So for the 498, this is the 2x2 version of the 494. 2x2 means it only has 2 antennas, or we are only using 2 antennas for this particular version, and we're using the vertical elements, this one here and this one here, and these are the high gain. So it's not using the low gain antennas like the 494. It totally looks the same as the 494. Same enclosure, but inside we are just using 2 antennas. It's 2x2 MIMO, as I mentioned, which are the vertical, and we are using the vertical elements on the side. It's still a dual band Wi-Fi antenna covering 2.4 and 2.5 and 5 to 7.2 gigahertz. So that's covering until Wi-Fi 6E with a peak gain of 9.8 dBi. So you'll get that reach to users that are away from or at a distance from the access point. IP68 rated from dust against dust and water ingress. The antenna is foam filled, so water cannot get in through there during harsh days or at sea. The radome is salt water and UV protected. It can still operate from -40 to 80 degrees Celsius. And now this antenna comes only with 2 cables, just because we have 2 antennas. So there's a cable terminating from one of the antennas and this other antenna. That's why we only have 2. And they terminate with SMA male connectors. They are both 2 meters and they're HDF 195 cables. As same as the 494, we will provide adapters, the RP SMA male to SMA female adapters for you to be able to connect to your preferred access point. So where else can you use these 2 antennas? That's the 494 and the 498. So apart from it being used in the marine and coastal, which is actually the primary vertical or the primary industry this antenna was designed for, you can also use it in the urban and rural areas and the commercial and industrial areas if you want to distribute Wi-Fi. And you will do this by doing like a pole mount, and this antenna is provided with an L bracket, as you will see down the slides, and you can mount it as high as possible and make sure that you have proper distribution in the areas where you actually need Wi-Fi. So let's dive into the measured results. So we measured both the 494 and the 498, and this is the VSWR measurement. So on the left here is the 494 measurements. So remember, 494 has 4 antennas, 498 has 2 antennas. The Wi-Fi 1 and 2, these are the high gain antennas, which are the vertical elements. 3 and 4 are the low gain antennas, which are the horizontal elements. If you look at the lower band, Wi-Fi band there, the VSWR is actually lower than 2 for all the elements, which is actually very good for this antenna, and it has actually met the specifications that were given for this antenna. So on the upper end of the Wi-Fi band, which is 5 to 7.2. So we only have a few elements that are just above 2, but are lower than 2.5. So this is still acceptable and it will function as expected. For the 498, this is the high gain antenna. So it's just below 2 for whether it's 2.4 to 2.5 or the higher Wi-Fi band, which is perfect and will provide good coverage and function as expected. For the gain, for the 494, we specify 2 gains. So we have the 5 dBi. So this is the peak gain for the low gain antennas or the horizontal elements, and 9.8 is the peak gain for the vertical elements. So on top here, so these are the vertical elements here, and then these are the horizontal elements of the antenna. On the from 2.4 to 2.5, if you have a look here, for the horizontal elements, you'll get like 0.5 as a peak gain there, and you'll have a peak gain of like 7 for the high gain antennas or the vertical elements. And from 5 to 7.2, you'll have a peak gain of 9.8 for the vertical elements and 5 dBi for the horizontal elements. So as I mentioned earlier, just having a mix of low gain and high gain will work perfectly in distributing the Wi-Fi signal, especially if you're close to the access point or you're further away from the access point. You'll still get good coverage and accessibility to the Wi-Fi that is provided in the water vessel. So for the 498, it's basically just this top part because it's just using the high gain elements, which are the vertical elements, and it has a peak gain of 9.8. So what the 498 gives is reach, or it gives you distance. So it gives you coverage further away from the access point. So users that are further away or situated further away from the access point will still get coverage and they'll still get good signal. So for the radiation patterns, we'll start with the 494, just to mention that we combined all the 4 antennas to come up with these patterns because that's how a user will actually use them. They will use all the 4 ports that come with the antenna. If we look at the elevation is the side view. So here, that's why we put a ship watermark, and when you look on the side there, remember 494 has 4 antennas. So we have the vertical and the horizontal. The vertical on the elevation will be radiating sideways, and the horizontal ones will be radiating up and down. So it's kind of giving like a 360 degrees coverage to everyone on board there. So it's kind of like an omni pattern coming in there, and it will give coverage to everyone on board the water vessel. Even if you look at this one, it's giving coverage sideways, and it's giving coverage upwards and downwards, and also from 6 and 7.2. If you do a top view, which is the azimuth, there are no dips or nulls in the pattern. So everywhere that you see there, if you see the radiation patterns there, they are constant. And these are constant omni pattern across all frequency bands from 2.4 all the way to 7.2. There are no dips. There's no areas where a user will stand and not have Wi-Fi signal. So this is the 494. So if we look at the 498 is just the vertical elements. On the side view, which is the elevation, they should be radiating sideways, which is what you are seeing here with a narrower beam width. And then there's reach there. So the users that will be further away will still be able to get reception and good signal. And if you look at the azimuth again, these are, I can say, they're acceptable. So you will not have signal wherever you'll be on board the ship or the water vessel. And it's almost, if I look at this 6 to 7.2, apart from that, but this is not detrimental or something like that, you'll still have signal. It's only that it's not perfect signal, but you'll still have signal. There are no nulls or dips anyway, so it's still acceptable. So just to show you the dimensions, Fanuel helped me here just to put it into perspective. It's a long antenna because it's using the 402 enclosure, and this here on the right there, Fanuel is holding is the 496. So this is the SISO antenna. So it's only one antenna here, and then this is the 402. So it will actually be longer. Remember, 494 and 498 will use the same enclosure, so it will have the same length, and it's bigger because now we have more than one antenna in the same enclosure. Remember, the 494 will have 4 antennas in here, and the 498 will have 2. So it definitely will be longer than the 496. And this here is the length minus the L bracket that comes with it. So it will have a length of 645.71 millimeters and a diameter of 70.42 millimeters. So they come standard with a stainless steel L bracket and a marine bracket 40. The mounting options, there are only 2 mounting options for these 2 antennas, the 494 and the 498. We have the pole mount. Pole mount options will be using the provided L bracket. We provide the U-bolts there and all these fasteners, and this can be used for rural, urban, and industrial applications. And for the marine, you'll use the bracket 40 that comes with the antenna, and of course this will be used for the marine and coastal applications. So in addition to using the bracket 40 for marine applications, you can use these 3 available marine mount brackets, and these ones are optional, so they'll be bought. They're actually bought separately from the antenna, and it gives you, depending on how you want to mount your antenna, you can either, if you want a flat mount, you can go with the bracket 37. If you want to mount it on a rail, you can go with the bracket 38, which is this guy here. Or if you want an adjustable bracket, you can go with the bracket 39. All these brackets are made of 316 grade stainless steel, which has superior resistance against rust, which comes in handy, especially to the salinity environment of the sea. As you see on the right there, all these brackets are used in conjunction with the bracket 40, and this bracket 40 comes with the antenna. So what are the key selling points for the OMNI-494 and the OMNI-498? So both antennas are MIMO Wi-Fi antennas. Remember, our current Wi-Fi antenna for marine applications is the 496, and it's a SISO antenna. So it's only one antenna in the enclosure, but now we've introduced the 494 and the 498 that have 2 or 4 antennas in the same enclosure. And this is important. It's important for improved performance and also coverage, among other advantages of having MIMO. OMNI-494 is made up of cross-polarised antennas, which is the vertical and the horizontal elements, important for polarization diversity and overall improvement of signal quality, reliability, and performance. The high gain antennas in the 494 and the 498 have a peak gain of 9.8 dBi, while the low gain antennas in the 494 have a peak gain of 5 dBi. So it gives you the best of both worlds and provide good coverage to both near and far users from the access points. Both antennas are dual band Wi-Fi antennas covering 2.4 to 2.5 gigahertz and 5 gigahertz all the way to 7.2. So it can be used with access points using old Wi-Fi technology and access points using the new technology, which is Wi-Fi 6E. And they both have exceptional omnidirectional patterns, as we saw in the previous slides. And both antennas are robust and all weatherproof for harsh conditions at sea. They are both IP68 rated against dust and water ingress. They are foam filled just to make sure that water doesn't really get its way in there. and they are fully saltwater and UV protected. And we have a variety of marine mounting brackets that give you options if you want for mounting your antenna on your water vessel.